In the previous problem, we converted measurements that stayed within the same measurement system. For example, we had a known measurement of 20 quarts. We wanted to change it into another unit, gallons, but that was all in customary measurement system. Or we had a problem where we had a measurement that we knew in grams and we wanted to switch it into milligrams, but both of those are within the metric system. For this next example, we are going to look at converting from a unit of measure that's in one of our systems and changing it into a unit of measure that is in the other system. For that, we need a table of measurement equivalencies or facts, as you see at the top of this page. These are ones that I personally do not have memorized. Most of the ones on the other table, just from going through life for as long as I have most of those memorized. These I do not. I have to have the facts somewhere that I can look back at. So we provided that table here for you. The setup and the solution is going to be determined the exact same way as before, but we wanted you to see what happens if you're switching with or outside of the same system of measurement. So, for example A, we are given a customary measurement of 45 feet, and we want to see how many meters that is equal to, and meters is part of the metric system. We still have to look at the table of facts that we have and find a fact that has those two labels in it. So I'm looking for something with feet and meters. And I see that in this one right here, where it says 1 meter is the same thing as 3 and 281 thousandths feet, or 3.281 feet. That's the fact that I'm going to use to set up my proportion. So now I'm going to go down here to my workspace for problem A, and I'm going to set up my proportion, just like I had for the other problems. And I know that I am comparing feet to meters. So I'm going to go ahead and put my labels in my proportion. The fact that I know, back up here at the table, is that 1 meter is 3.281 feet. So 1 goes with meter, and the 3.281 has to go on top where I put the label feet. Then I look at what I have in my actual problem. I have a measurement of 45 feet. So that number has to go up here with feet, and it's the number of meters that are missing. So that's going to be my unknown value. I will call it X. And now my job is to use my proportion solving skills to determine what the value of X is. In this problem, it doesn't look like a mental math problem to me because I don't know about you, but I do not know what to multiply 3.281 by to turn it into a 45. So instead, I'm going to use a different method, which was the cross products method. So when I do that, I know that 1 times 45 has to be the same thing as my 3.281 feet, or X, excuse me. So 3.281 times X, or 3.281X, has to be the same as 1 times 45. Well, that part I can do in my head. I know 1 times 45 is 45. And now I need to solve that equation for X. So to do that, I have to divide this side, the left side, by 3.281 to make that go away, which means I need to divide the 45 by 3.281, because whatever I do to one side of the equation, I absolutely have to do to the other one. So when I do that division, I get a really long, kind of ugly number, but I'm going to round it. So I turn my equal sign into what I call the squiggly equal sign. Some students call it the bacon. To let everybody know that this is not going to be an exact answer, I have done some estimating here. I've done a little bit of rounding in my answer, and I'm going to round that answer to the nearest tenth, and I get about 13 and 7/10, or 13.7. So 45 feet turns out to be almost the same thing as 13.7 meters. And we are done with example A.